Good morning. Happy Friday, last day before vacation. In this video lesson, we're going to talk to you pretty quickly about how we can write and solve equations. We've been spending a couple weeks on solving equations. Here, we're going to see a few problems today about perimeter that require you to first write your own equation, and then you're going to solve that equation to figure out some things about these problems. Perimeter, as you should recall, we talked about it earlier this year. You've worked on it in past grades. That's a measure of the total distance around the edge of a figure. So if we have triangles, squares, perimeters, say how long is the distance all the way around the edge of the figure. So for your guided problems today, part 1 asks you, when we look at this blue rectangle here, to write an expression that could be used to determine the perimeter for the blue rectangle. Part 2 is going to actually tell you the perimeter for the blue rectangle. We learned that the blue rectangle has a perimeter of 62 units. And they're going to ask you to then write an equation that could be used to determine the value for x, and you're going to go on to determine the value for x and give us an image of the whiteboard. So what I would ask you to do right now for parts 1, 2, and 3, go ahead, pause the video lesson, work with your partner or your neighbor, and we would expect at this point that you should be able to do all 3 parts here. So again, pause the video, try to work through all of the guided problems with your neighbor. And as you come back, I'm going to work pretty quickly through each of these 3 parts today. Part 1 asks us to write an expression. That's numbers and variables joined together with addition, subtraction, multiplication, or division. So an expression, not going to be an equation yet, that could determine the perimeter for this blue rectangle up here. So the big thing we need to see, and I've drawn the blue rectangle up on my whiteboard, so we'll full screen that. Perimeter is the distance all the way around. So my perimeter is really just going to be these 4 sides added up. I have 2 versions, or 2 of the lengths that are 2x plus 4. So I could write 2 times 2x plus 4 plus 2 of these, x plus 3. And that right here for part 1, that's the expression we're looking for. Some of you may have written this instead of in factored form like I did. Some of you may have written it as 2x plus 4 plus 2x plus 4 plus x plus 3 plus x plus 3. That would be okay too. That's just adding all 4 sides up, but instead of putting them in factored form, expanded form. There's benefits to both methods. Here we could add them all together. Here it's just a little less complicated in the beginning. So again, 2 different ways that we could write this. The perimeter is just going to be all 4 sides added up. Part 2 asks you to assume that the blue rectangle up here had a perimeter of 62 units and to write an equation that could be used to determine the value for x. So I'm going to go ahead, full screen this whiteboard, and before we're going to switch over to another one and write a new equation here for that, I'm going to actually take the factored form expression and write that there. But again, you could be using your expanded form as the left side of our expression here as well. So we have 2 times 2x plus 4 plus 2 times x plus 3 equals the perimeter, which we now know is 62. So I took that expression that could be used to find perimeter. Now that we know it's equal to 62, we could set that whole expression equal to 62. At this point, we need to solve the equation. One method would be to distribute out these 2's, but I see an even number here, and these are just 2's. I'm going to divide the entire equation by 2, or that's really like multiplying the entire equation by 1/2. So dividing the whole equation by 2 is going to cancel out this 2, cancel out that 2, and 62 divided by 2 would just get down to 31. So I know 2x plus 4 plus x plus 3. Let's clean up that 4. Gives us 31. And at that point, we should see 2 variable terms on the same side of the equation. 3 constants. I'm going to combine the 2 constants on the same side. We get 3x combining the x's. Positive 7 equals to 31. 3x is going to equal 24 after we subtract 7 from both sides of the equation there. And then ultimately 3 times 8 is what would give us 24. So from inspection, I know x equals 8. If I didn't know that, I could divide both sides of this equation by 3. And 24 divided by 3 would equal 8. So that shows us part 2 and part 3 all together. If we put that together into an equation, if we solve for x, now we can start to see some of these examples of why real-world problems might have a bunch of x's or a bunch of different variable terms in them, and why some of this factored form and expanded form work we've done in the last couple weeks could help you solve real-world problems. As you go today, the problems will get a little bit more difficult. There's not a lot of them. We're going to ask you to do Khan Academy or 10 marks once you get through the guided practice work. It shouldn't take too long today. If you have questions, please see me or use Classroom Q if I'm busy and you need to get my help still.